The problem that we are going to discuss today is optimal denomination. The problem appeared in July 21 long challenge and has a difficulty level of easy. The prerequisites to solve this problem are prefix and suffix precomputation. The problem statement goes as follows. It is given that you have n employees where the ith employee has salary AI. That is, mostly an array will be given to us in the input with the number n and then the n integers denoting the salary of each employee. Then it is given that you want to pay them using a denomination that you create. So we have to create our own denomination. Let's see how. You are also eco-friendly and wish to save paper. So we want to pay them using as few notes as possible. So remember this, that we have to use as few notes as possible. So we have to find out the minimum number of notes required if you can alter the salary of at most one employee to any positive integer that you like. So we have to answer that what is the minimum number of notes that we are going to need to pay the salaries, but we also have the power to change at most one person's salary to any number that we like, and it should be a positive number obviously. So the positive integer that we will be choosing to pay the salaries, and it will be the value that each note will be containing, so it is going to be called the denomination. So each employee must receive exactly the value of his her salary and no more. It means that if an employee has salary 10 and if let's say you are using the denomination of 3, it's not possible to pay his salary. Why? Because you cannot pay exactly the amount 10 using the number 3. So you have to take care that each employee must receive exact amount of his salary, no more and no less. So this is the question. Now let's take a small example to understand. So let's say that there are three employees in our company and their salaries are 8, 4 and 2. So what happens if you don't change the salary of any person? Say it's given that you can change the salary of at most one, right? So it can also happen that you don't want to change anyone's salary. So in that case, what we can do is, clearly you can see over here that if we use the denomination of 2, then 8 will need total 4 notes, 2 will need 2 notes, and these 2 will need 1 note. Okay, so total 4 plus 2 plus 1, that is how many notes? 6 plus 1, 7 notes are needed if we don't alter the salary of any person. But let's say we decide to alter one person's salary. In that case, you can see that one of the most optimal ways would be that let's convert this salary to 4. Okay. And now what we can do is we can use the denomination of 4. So two notes will be needed here, one note will be needed here, and one note will be needed here. So 2 plus 1, that is total 4 notes. So if you try all the possible combinations, you will know that 4 is the minimum amount of answer. The answer cannot be less than 4. So this is a small example that I have taken. I hope everyone has understood the problem. Now let's see how to approach the solution. The solution approach goes as follows. First of all, let's think for a solution if we are not going to do any update in the array. So the first subpart of our solution is that if we are not doing any updates, so I am going to write here no updates. In that case, the array is going to be as it is, no value is going to be changed. So A1, A2, A3 all the way up to AN. Now, let's say that our answer, our denomination that we are going to choose has the value x. So, what properties x should satisfy? First of all, each of these numbers a1, a2, a3 should be perfectly divisible by x. Only then you can pay the exact salary, right? And secondly, because we want minimum number of notes, x should be as large as possible. So this gives us clear hint that what x should be. That is, x should divide all the numbers and it should be as large as possible. So definitely x should be the GCD of all the numbers. GCD stands for greatest common divisor. So this is pretty common concept in maths. So greatest common divisor. If we find the greatest common divisor of all these numbers a1, a2, a3 up to an, and that is going to be our x, then we can easily find the original answer. And what is that answer? Answer is basically sum of all elements. So a1, a2, that is the sum of all salaries. This is going to be the sum, and the total number of notes will be, we have to divide this number by the denomination. So that denomination is x. So for the first case, that is a smaller problem where we are not doing any updates, the answer is simply sum of all numbers in the array divided by the GCD of all numbers. So now we know how to minimize the answer for an array if there are no updates. Now let's see the approach if we are allowed to update exactly one number. So let's see. So if we are allowed to update exactly one number, so as per the question it's given at most one. So we are seeing both the cases, no update and one update. So first case is done. This is the second one update. So in that case, the initial array will be A1, A2, A3, all the way up to AN. So if we are updating one number, it can be either A1 or it can be A2 or A3 or it can even be AN. So any one of these numbers. So what we are going to do is we'll try and update each one of these numbers one by one. That is, first I'll update A1 and see what is the answer. Then I'll update only A2. A1 will be original. Then I'll see the answer. So I will check all the possible cases. So how to do that? Now let's say there is some ith element that I am updating. Okay, so let me again draw here the array. So it's A1. So this is how my generic array would look like. Now let's say I am updating some ith element. So this is the ith person salary I am going to update as per my wish. So let's keep this value aside for a moment. This one marked in green box. For the rest of the people, the question still remains that we have to minimize the number of nodes. So what are the remaining numbers? The remaining numbers are from A1 to AI minus 1 and then AI plus 1 to the last number AN. So for these numbers, we have to minimize the answer, right? So again, what we can do is we can find the GCD of not all numbers this time, but from A1 to AI minus 1 and then from AI plus 1 to AN. And this can be our optimal denomination, let's say x. So the answer will be minimized for all these other people. But what about the ith person? Now see, we can update the value of AI to any positive number of our choice. And we know that at least he is going to get one node. So what we'll do is we'll set the value of AI, we'll replace AI by x so that he gets exactly one node. So what will be our answer in this case? The answer in this case will be whatever is the total sum of all elements minus AI. Why? Because this number is not included in our sum. Now, this value will be divided by our optimal denomination, that is x, and extra one node will be needed for the ith person. Correct. So let me just mark this answer in a red box. This is going to be our answer. So total sum minus AI divided by x plus 1. And what is x? X is the GCD of numbers, all numbers except AI. Let me write that as well. X is GCD of all numbers except AI. Because for other people the problem is still the same, that we need a denomination that is higher enough and also it divides everyone. So basically GCD. So in this manner, this I can be traversed from 1 to n. That is right now I had shown a general example, but in the actual question you have to try it for all possible people. That is, first try if the first person is replaced, what is the answer? then go for the second person, then go for the third person, then fourth, and so on. So all these people will be replaced, and AI will take all possible values from A1 to AN, and accordingly X value will also be changing, but the formula will still remain the same. Now the question is, only question remains is that how do you compute this GCD value in an efficient manner? Because every time we cannot run a for loop, right? I cannot run a for loop from 1 to I minus 1, then again from I plus 1 to n. If we do that, we are basically making our solution pretty slow. You can calculate the complexity. It will come out to be for each number. So there are total n numbers. We have to calculate the GCD again and again. So it's safe to say it will be O of n square, right? The complexity will be order of n square, which is going to be very slow. So we need an efficient way to calculate this GCD. So let's see how to do that. So the concept underlying here is that we need to pre-compute these GCDs. So what we can do is, if the given array is A1 to AN, so what we can do is we can maintain two arrays. First will be the prefix array, prefix GCD, and the second will be the suffix GCD. So what will these two arrays store? The prefix of I, that is the ith element in the prefix array, will store the GCD of first I element, that is A1, A2 up to AI. And similarly, the suffix array, suffix of I, will store the GCD of all elements from ith element to the last element. So from AI plus 1 all the way up to AN. So this can be easily calculated in order of n, because we'll just run a simple for loop and keep taking the GCD with the previous number. That is to write the relation, prefix of I will be GCD of prefix of I minus 1 comma AI. That way you get the ith prefix number. Similarly, for the suffix, we'll start from the right hand side, and suffix of I will be basically GCD of suffix of I plus 1 comma AI, right? So in this manner we can run a simple for loop where I varies for prefix array from left to right and the I varies from right to left for the suffix array. So once these values are calculated, now it's easy to calculate our original answer. So for at most one update, let's say we are trying to update the ith element. So the ith element is getting updated. So definitely the previous element will be AI minus 1, next element will be AI plus 1, here there will be A1, here there will be AN. So we need GCD of all these underlined elements. How to get that? Easy. GCD till here from first to this element is prefix of I minus 1. GCD of all these elements on the right hand side, it is suffix of I plus 1. And if we take the GCD of both these numbers, you get the GCD of all these red numbers. And that's it. You have got your optimal denomination, that is X. Because these values are pre-computed, so X can be calculated in order of 1 for a particular I. And once you have that, getting the sum of elements is very trivial. Why? Because as already stated, we'll store the total sum of all elements, and then we can just write the answer will be total sum minus AI, right? Okay, just write like this, minus AI divided by X plus 1. Why plus 1? Plus 1 because the value that we are changing AI, it will be changed to X, so therefore it will require exactly one node, and the remaining numbers, they will require these many nodes. Total sum minus AI divided by X. So like this we'll calculate the answer for all possible I, and we'll keep a track that which is the most minimum, and at the end we'll output the answer. So that is pretty much the solution. Now let's see the implementation in C++. Also, before we go to the implementation, there are some corner cases that you need to take care of, Like for example, if you are updating the first element, so the array will be A1, A2 up to AN. And if you are updating the first element, then there are elements present only on the right hand side, not on the left hand side. So in that case, the GCD of the previous elements, you have to take it as 0. Here you can simply take suffix of 2, and then both their GCDs can be taken. Similarly, there can be the same case for last element as well. So if you are updating only the last element, in that case there will be elements only on the left hand side, right hand side no elements. So in that case, here GCD will be 0 and here it will be prefix of n minus 1. Then this will be your optimal denomination, GCD of both these numbers, and then you can continue as stated. And one more corner case is that if there is only one number in the given array, just one number, this is your array, okay, only one number. In that case, there is no need to do all these computations and all, just simply output the answer as 1, because whatever is his salary, you will keep your denomination as the same. So the answer is going to be just 1. So these are some corner cases. Now we are good to see the implementation. So the implementation goes as follows. First we take the input for number of test cases. Then I create a variable n and sum, because I want to calculate the total sum. Then I take the input for n, take the input for the array, and at the same time I am computing the sum of all elements. Edge case handling, that is if n is equals to 1, simply output 1 and continue to the next case. Then we have to calculate the prefix and suffix GCD arrays. So how do we start that? I just set prefix of 0 is equals to ARR of 0, because I am following 0 based indexing. Okay, although the discussion was all in 1 based, so just convert it to 0 based. Then the first element will be as it is. Then for all the next elements, prefix of I is nothing but GCD of prefix of I minus 1 comma current element, as discussed. Similarly for suffix, it will be from right to left. So last element is equals to the last element. Then from n minus 2, I go till 0 from right to left, and suffix of I is equals to GCD of suffix of I plus 1 comma current element. So in this manner, my prefix and suffix GCDs are calculated for each possible I. Now this is the answer if I am not doing any update, that is if I am doing no update, the sum will be the sum of all salaries divided by GCD of all numbers. So GCD of all numbers can be either prefix of n minus 1 or suffix of 0, whatever you like. This is my one answer, candidate answer. And then for each element, now I am going to update that element and minimize my answer. So my optimal denomination is k. So k is nothing but GCD of prefix of I minus 1 comma suffix of I plus 1. But here there is some case handling, that is if I minus 1 itself is going outside the array, then I need to take 0 as my GCD. Similarly, if I plus 1 is going outside my array on the right hand side, then in that case also I need to take 0 as my GCD, as discussed in the solution in the very last, the edge cases, corner cases. So once we have our optimal denomination, the answer is simple. I have to minimize my answer. So answer is equals to minimum of answer comma sum minus AI, that is the total sum minus the current element divided by k plus 1, as discussed. So I do this for all I from 0 to n minus 1 and finally output my answer. So that pretty much completes our implementation. It is easy in C++ and other languages as well. Just you need to compute these GCDs earlier, so that you can find the optimal denomination in order of 1 rather than order of n. So now I would like to tell you guys about competitive programming tutorials that we have at CodeChef. If you are new to CP, you can learn all these topics for free by visiting our page on CodeChef website. These are taught by our expert educators. And if you want even more structured content, you can always opt for our plus subscription on Unacademy, where you can use my referral code DarshanCool25 to get instant 10% discount.